what we'll be exploring this time is graphing inequalities. Inequalities involve the signs such as less than, greater than, less than or equal to, or greater than or equal to, as opposed to the equal sign. So this is what we're going to be exploring on this exercise today, is graphing inequalities using these signs. All right, let's erase this and let's start working our first exercise. Okay, once again, it's very important that we know this formula, y equals mx plus b, because the y equals mx plus b contains the things that are important to be able to graph a line. The b is the y-intercept and the m is the slope. So whenever you're looking for the slope of a line, you look for the number that is in front of the x. And whenever you're looking for the y-intercept, you look for the number that follows the x. Okay, but it always has to be exactly in this format. Okay, if it's in any other order, it doesn't work. Okay, so you've got to make sure it's in this order. All right, so this one looks like that, y mx plus b. See, so that one works. So what is the y-intercept of this one? That would be plus 1. So we come over here to the origin. Plus 1 means that we should go up 1. So we put our dot here at 1. Our slope is -3. -3 is the same as -3 over 1, or it can be 3 over -1. Doesn't matter which one you choose. Let's choose this one. Okay, so let's go. This tells you to go down 3. So we go, starting at the y-intercept, we go 1, 2, 3 down. And the positive 1 on the bottom tells us to go 1 to the right. So we go 1 to the right when we make our point. Then we go down 1, 2, 3, and we go right 1, and we put our dot. Now, when we're drawing our line, okay, the way I have to draw the line on this one is I have to first draw this solid line like so. Okay, let me draw my arrows on the end of it, because we want to make sure that we understand that the lines go on infinitely in each direction. Now, see this sign right here. This is an inequality sign, which means less than. When it says less than, that means that the line that you're going to draw is not going to be a solid line. It is going to be a dashed line. Because if it's a dashed line, that means the answer is not included on the line. Okay? You cannot find your answer on that line. Okay? Now, it says is less than. Okay. When it says is less than, that means that you graph below the line. Okay? If it said greater than, you would graph above the line. So let's graph below the line. So let's grab this color. Okay, which one is above and which one is below the line? Okay, this side would be above, this side is below. So that means that if we were graphing this inequality, we would shade this side of the line. And what that means is that anywhere on this side of the line, you will be able to find a point that solves this inequality here. So let's just choose one. Let's choose, let me get a point here. Let's choose this one. Okay, we'll choose this point. All right, what is that point? Let's go 1, 2, 3, 4 to the left, and 1, 2, 3, 4 up. All right, 4 to the left, that means -4, and 4 up means +4. So that is the point that we've chosen. Remember, this is always in the form of x and y. So we come up here and we go y, which is 4, is less than -3. See, we take the -3 here. 3x, -3x means -3 times x. This is a -4. So we put -4 here, plus 1. So now, we've got 4 is less than negative times negative. That's 2 negative signs. Anytime you have 2 negative signs in multiplication or division, that is an even number, and an even number of negative signs means positive. So that gives you positive 12 plus 1, which gives you 4 is less than 13, which is a true statement. Good for us. That means that that satisfies it. Just to make sure, let's choose a point on the other side. Let's choose, well, we can't see that. Let's choose another color. Let's choose this point right here. Okay? And let's see if we come up with the same a good answer again. This point is 0, 1, 2, 3. So it's 0 and +3. Let's plug those numbers into the equation, inequality. The y is 3, so we go 3 is less than -3. Oh, that's horrible. There we go. -3 times x is 0 plus 1, which gives us 3 is less than, what's -3 times 0? That's 0. Plus 1 is 1. Now see, that's not true. That's not true, which means that that is not a solution to this inequality. And if you notice, that is on the wrong side. So it shouldn't be a solution. See, so it's a good idea to choose something on the side that is the solution and to see if it comes out to be a true statement. And then if you want to be sure, choose something on the other side as well to verify that it gives you a false statement. Okay, let's try this one. This one says is greater than. If it says is greater than, that means that you're going to be shading above it. Okay, and once again, it just says greater than, so that means that the answer is not contained on the line. So when you draw your line, it's going to be a dashed line. All right, what is the y-intercept? The y-intercept of this one is the b, which is, oops, got to get our color here, which is right here. It's -3. So we come to the origin and we go 1, 2, 3, and put our dot. The slope is here in front of the x. It's 2. That means it's 2 over 1, or it can be -2 over -1. So let's try this. We start at 3. Let's use this one. It means we go up 2 and right 1. 1, 2, and right 1. 1, 2, and right 1. So now we can draw our line. Okay, goes through there. Let's extend it in the opposite direction. We need to put our arrows on the end. There we go. And once again, remember, because it says is greater than, that means that it's got to be a dashed line, okay? So let's make this our dashed line. And once again, that means that the answer is not contained on that line. Now we've got to shade the side that contains the correct answer. This says is greater than. Okay, which side is greater than? Okay, it's above the line. Which side would you consider to be above the line? It would be this one. So we would shade this side, okay? So our answer would be on this side of the line. And if we wanted to check, we could check a point that was near here. Oh, look, this would be an easy one to check. Let's check 0, 0, the origin. So let's come over here, and we've got 0, comma, 0, which is right here, and it's in the shaded area. So that means that 0 is greater than 2 times 0 minus 3. And that would give us 0 is greater than, 2 times 0 is 0, minus 3 gives us minus 3. So is 0 greater than minus 3? Yes, it is. So that means that that is a solution. So now we check the other side. Let's just come over here and we'll check this spot right here. It's on the other side. It should not come up with a true statement. This is 1 and then down 1, 2, 3. So that point is 1, negative 3. So let's check. Y, which is negative 3, is greater than 2 times 1, which is the x, minus 3. So that gives us negative 3 is greater than, 2 times 1 is 2, minus 3. So that gives us negative 3 is greater than, 2 minus 3 is negative 1. Is negative 3 greater than negative 1? No. And see, we came up with a false statement, which is what we should come up with because this is not in the solution area. Now, if we come back to this problem over here, let's say that this had been y is less than or equal to, okay? Less than or equal to. How would that change things? Well, the way it would change things is that instead of this being a dotted line or a dashed line, your answer would be a solid line, okay? So if it says less than or equal to, the line will be solid, and what that means is that the answer would be contained on that line also. So the answer would be over here, and it would be on that line. So the same thing would apply here. If this said, if this said greater than or equal to, then instead of this being a dashed line, what we would have is a solid line. Okay? So we would have a solid line, and what that means is that the answer, once again, the answer is contained on that line or in the shaded area.